This lesson is all about ratios. Before we begin, let's review equivalent fractions. Find the number that makes the fractions equivalent. 1/2 is equivalent to 6 over what? We are looking for a new denominator. Remember, we look at the given numbers. We have both numerators. To get from 1 to 6, we multiply by 6. We're looking to either multiply or divide. In this case, the number was getting bigger, so I know that we multiply. Whatever you do to the top, you must do to the bottom. 2 times 6 equals 12. So our equivalent fraction is 6 over 12. Let's try b together. In this case, we have both denominators, 5 and 45. So we must ask ourselves, what can we do to 5 to get to 45? In this case, the number is also getting bigger, so we know that we multiply. 5 times 9 equals 45. Whatever we do to the bottom number, the denominator, we must do to the numerator, the top number. 3 times 9 is 18. Therefore, 3/5 is equivalent to 18/45. Try C and D on your whiteboard and then check your answers. Remember, in a fraction, the top number is called the numerator. The bottom number is called the denominator. In this example, one part is shaded in. That represents the numerator. The bottom number is the total number of parts. 1, 2, 3. So we have one of 3 parts. Let's look at this next example. Team A won 2 games, lost 1 game, and tied 4 games. What is the fraction of games won? Let's see. They won 2 games. 2 games will represent our numerator. Now we need to determine the total number of games played. Team A won 2 games, lost 1 game, and tied 4 games for a total of 7 games. 7 is our denominator for the total games played. From the last page, we know that Team A won 2 out of a total of 7 games. Team B also won 2/7 of their games. Did Team A and Team B have the same results? No. Team B lost 3 games and Team A only lost 1 game. We need another way to compare them. Which team had better results? Fractions can only compare 2 numbers. We need another way to compare these results. Ratios allow us to compare more than 2 numbers. In this case, we are going to compare 3 numbers: wins, losses, and ties. Team A won 2 games, lost 1 game, and tied 4 games. To represent this as a ratio, we separate the numbers with colons. Where 2 represents wins, 1 represents losses, and 4 represents ties. We must represent Team B's results in the same order: wins, losses, and ties. Team B won 2 games, lost 3 games, and tied 2 games. Now it is more clear that Team A has a better record. They only lost 1 game, whereas Team B lost 3 games. Let's look at some other ratios. On your whiteboard, write down the ratio of boys to girls in your class. Pause the video and write it down on your whiteboard. In 6C, we have 5 boys to 3 girls. we can reverse the ratio and represent it as girls to boys. In that case, we would say 3 to 5. The order of the numbers is important in ratios. There are two types of ratios. Ratios may be part to whole or part to part. This will make more sense with an example. Let's look at A together. We want to represent vowels in the word band to the letters in the word band. How many vowels are in the word band? That's right, there are 1. 1 will be our first number. We're going to use a colon to separate the numbers. The second part of our ratio is letters in band. There are 4 letters in the word band. Therefore, our ratio is 1 to 4. This would be a part to whole ratio. Whole because the second number includes all of the letters in the word band. Let's look at the next example. Vowels in the word blog to consonants in the word blog. Again, there is 1 vowel in the word blog. However, there are 1, 2, 3 consonants in the word blog. This is also a 4-letter word. However, the second part of the ratio is only concerned with consonants, not the total number of letters. Therefore, this is a part-to-part ratio. Let's try C together. You've been asked to write a ratio that compares buses to trucks in the school parking lot. Is this a part to whole or part to part ratio? Write it down on your whiteboard now. This would be a part to part ratio. It is not asking for the total number of cars in the parking lot, simply the number of buses and the number of trucks. Had it asked for the total number of vehicles to the number of trucks, it would be a part to whole ratio. School buses to buses. Therefore, there must be other types of buses in a parking lot. In this case, school buses is the part, and the buses is the whole. This is a part to whole ratio. School days to days of the week. Days of the week is total number. This ratio is a part to a whole. Now try page 116 in your Jump Math book before moving on to the next lesson.